Let's look at solving systems of equations. Today, we're going to solve our systems by using the elimination method. In our next video, we will take a look at what it looks like to do it with the substitution method. What is a system of equations? A system of equations is where you have multiple equations with the same variables, and these variables are the same value in each equation. So this x is the same thing as this x. This y is the same thing as this y. And the point of a system is we are trying to find a value of x and a value of y that will make both of these true at the same time. So today, we're going to figure out how we can do that using the elimination method. One note about using the elimination method: we know that whenever we're working with an algebraic equation, whenever we're working with any equation, say x plus 4 is equal to 3, whatever we do to the left side of the equation, if we do the same thing to the right side of the equation, we'll still have the same thing. If I subtracted 4 from both sides, I'd get x is equal to -1. I can do that as long as I do the same thing to both sides. When we use our elimination method, we're going to be adding two equations together. And the reason that works is because if I have, let's add these two equations together, just for an example. If I have x is equal to -1, if I add x to this side and I add -1 to this side, that is the same thing as just adding -1 to both sides. Because this x is equal to -1, I can add this x to this side, this -1 to this side, and I will still wind up with a valid equation. We would have 2x plus 4 is equal to 2. That is still a valid equation. Dividing everything out by 2, we would have x plus 2 is equal to 1. So x is equal to -1. We wind up with the same thing. So that is the fundamental property that we're going to be using whenever we do our elimination method, is that when we add two equations together, we're allowed to do that because it's like adding the same thing to both sides of an equation. Let's take a look at our first example. For example 1, we have -4x minus 2y is equal to -12. And we have positive 4x plus 8y is equal to -24. So this is our system that we need to solve. Remember how I said we're going to add the equations together? This one is set up very nicely. When we add them together, we have a -4x and a positive 4x that will cancel out. Because if you add a -4 of something and a positive 4 of something, you get 0 of those things. So this will wind up being 0x, which we can just disregard. So let's do that. -4x plus 4x is going to be 0x's, which we'll disregard. Then we have -2 plus 8 is going to be 6y. Adding our constants together, our constants that are on one side, adding them together, we have -36. From there, divide both sides by 6 so we can isolate y. Y is equal to -6. We have found one of the two variables. Now, we need to substitute this -6 back into one of the equations to solve for x. To do that, we're going to have, let's use the top one. -4x minus 2 times -6 is equal to -12. This is going to be -4x plus 12, because a negative times a negative makes a positive, is equal to -12. Subtracting 12 from both sides, -4x is equal to, whoops, I've done that wrong. Subtracting 12 from both sides, -4x is equal to -24. Dividing both sides by -4, x is equal to +6. So this is our solution. We have y is going to be equal to -6, and we have x is going to be equal to +6. To write out the solution formally, we're going to write it as an ordered pair. So that means we're going to write it like it's a point that we would use on a coordinate plane. We have our x value and our, whoops, not just a y, we have our y value. So it's going to be written in the form x comma y, and this is the final solution that we have for this system of equations. For our next example, we have 4x plus 8y is equal to 20, and negative 4x plus 2y is equal to negative 30. So very similar to the last one, we can see when we add them down, our x's are going to cancel out. So let's go ahead and do that. This is going to be 0 x's, which we can disregard. And then this is going to be 10y is equal to negative 10. 20 plus negative 30 is negative 10. This means that y is equal to negative 1. We substitute this back into either of the equations. Let's use the bottom one. Negative 4x plus 2 times negative 1 is equal to negative 30. This multiplied out is negative 4x minus 2 is equal to negative 30. I have everything as a negative, so let's go ahead and convert that to a positive. And the way we do that is we multiply both sides of the equation by negative 1. And I'm going to resume up here. So we'll have 4x plus 2 is equal to 30, multiplying both sides of the equation by negative 1. Subtract 2 from both sides. 4x is equal to 28. And then finally, divide both sides by 4. X is equal to 7. So we have y is equal to negative 1, x is equal to 7. So we need to write our final answer as an ordered pair, 7, negative 1. And that is our final answer for this system of equations. So what happens if you are looking at a set of equations or a system of equations and there's not a perfect cancellation for you to just directly add them and get rid of one of the variables? Well, you can make a perfect cancellation, and here's how we do it. Let's address the problem. 5x plus y is equal to 9, and 10x minus 7y is equal to negative 18. There is not anything that we can add directly down to cancel out any variable, but we can convert one of the equations to make a perfect cancellation by multiplying both sides of the equation by the same number. We have a couple of options. We can convert this to a positive 7y, because that would cancel out with this negative 7y, or we can convert this to a negative 10x, because that would cancel out with this one. I like the second option. Let's convert this to a negative 10x. So to do that, multiplying both sides of the equation by negative 2, we're going to rewrite this system as negative 10x minus 2y is equal to negative 18. Then we have 10x minus 7y is equal to negative 18 as well. Adding them down, what we will get is we will get 10x plus, negative 10x plus 10x is 0 x's, which we will disregard. This will become negative 9y is equal to negative 18 plus negative 18 is negative 36. From there, divide both sides by negative 9. Y is equal to a positive 4. We now need to plug this y back into either one of our original equations. Let's do this one because there's nothing multiplied by that y. 5x plus 4, that is what our y was, is equal to 9. Subtract 4 from both sides. 5x is equal to 5. So x is equal to 1. Finally, write out our solution in ordered pair form, our x and our y, And this is our final answer for our original system. There are a couple of interesting situations that you might come across. In fact, there's actually two special situations that you can come across while solving out a system of equations. I want to address both of them here, so let's take a look at our first one. For the first one, we're going to have 2x plus 8y is equal to 6, and negative 5x minus 20y is equal to negative 15. So, in order to make our perfect elimination, we need to convert this top one so that this will be a positive 5x. The way you would do that is dividing everything by 2 and then multiplying it by 5. So this divided by 2 multiplied by 5 will be 5x. Divided by 2 is 4, multiplied by 5 is 20y. Divided by 2 is 3, multiplied by 5 is 15. Minus 5x minus 20y is equal to negative 15. Now, let's do our addition down to cancel stuff out. 5x minus 5x, or 5x plus a negative 5x, is 0x's. So we'll disregard that. And then we have 20y's plus negative 20y's is 0y's. So we can disregard that as well. This whole side now is equal to 0. 15 plus negative 15 is also 0. We have wound up with a true statement of a constant is equal to itself. By the reflexive property, we know that this is true. 0 is equal to 0. This is the first of our two special cases. And in this case, there are infinite solutions. There is no value that we could plug in for x and no value we could plug in for y that makes 0 not equal to 0. So this has infinite solutions. X could be whatever we want it to be, y could be whatever we want it to be, and the system would still remain true. So we have infinite solutions. For this system. Let's take a look at the other special case that you can run into. For this one, we'll have negative 3x plus 3y is equal to 4, and negative x plus y is equal to 3. To solve this one out, let's multiply the entire bottom equation by negative 3 so we can cancel out our y term. We will end up with negative 3x plus 3y is equal to 4. This times negative 3 will be a positive 3x. This times negative 3 will be negative 3y. This times negative 3 is negative 9. Now, when we do our addition, the x's will cancel out and we'll be left with 0. The y's will also cancel out and we'll be left with 0. So this whole side is equal to 0. Adding these together, we get negative 5. Well, 0 isn't equal to negative 5, and there's not any value we can plug in that would make 0 equal to negative 5. So this system has no solutions. Whenever you are left with two constants that are not the same, and they're set equal to each other, so that it's a false statement because 0 is not equal to negative 5, there are no solutions for your system. That is all I've got for you today. In our next video, we will take a look at how to solve systems of equations by substitution. If you found this video to be helpful, consider liking and subscribing, and if you have a topic you would like for me to cover in the future, leave it down in the comments below. As always, have a fantastic day.